Welcome everybody to this wonderful day. We're going to be talking about 10.05, the extreme value theorem, one of the fundamental theorems in calculus. So we're just going to review what extrema are and some things that we've summarized in previous classes. So we're going to find each critical number, but in this case we only have a graph. So to find those critical numbers, think about like your relative max and mins, 1, 2, and 3. So you'd have critical values at -2, 0, and 2. So I could say x equals -2, x equals 0, and x equals 2. We can do that with the derivative if we have the equation. But in this case, just looking for maxes and mins or horizontal tangents. Classify each as a relative, min, or max, or neither. Okay, so for both of these, we can see that these are maxes. So we can say max at x equals -2 and x equals 2. We can see that there's a minimum, a definite relative minimum, at x equals 0. So these were things that we already know and things that we've already kind of figured out using the first derivative test to find when things were going from increasing to decreasing. That told me a max, and from decreasing to increasing told me a min, and from increasing back to decreasing told me once again a max. Those are things we use the first derivative test for, but we can very easily see that on a graph as well. Now, today what we're going to be talking about is absolute extrema. So on this interval from -3 to 3, what are the absolute extrema? Now, why this is a little bit different is because now we have to take a look at the endpoints of the graph to see if those extend past our relative max and min. So let's start with the max. Does anything go above a maximum of 16 here? No. So our absolute max is going to be at x equals -2 and x equals 2. And that absolute max, so the max is 16. Okay, that would be the y value, the output in that situation. All right, so now when we look at the absolute min, we have two minimums here. We have a minimum here, which we would find from our critical point, but we also see that this endpoint here, okay, extends down, and that's what we're going to be talking about today. So we have to check our endpoints, and that definitely goes past that minimum value of 0. We go all the way down to -12 here, so we have an absolute min at x equals 3, which is -12, right? So just looking at the endpoints as an extra point here. So we can use our first derivative test to find relative minimums and maximums, but we have to also consider endpoints when we're talking about absolute minimums and maximums. So that's a key point. Let's talk about this example here today. So what we're going to do is just find the absolute max and min of this on that interval. So we're going to start by doing the first derivative test. And if you need those steps broken down for you, absolutely go back and take a look at those. But our first derivative test, just remember, is when we take the first derivative to find critical points. Sorry, that's 4x. And we set those critical points, or we set that derivative equal to 0 to find those derivative of critical points. So let's see, right here, we're going to have to factor out a 4x. That's going to leave us with an x squared minus 1. Now we would set each one of those equal to 0. And before I do that, maybe what I should do is I should factor this down into 2 perfect squares. Factoring makes this much easier to solve, and we have 3 different critical values. We have 0, -1, and 1. Now what we don't have to do this time is we don't have to necessarily create a number line, because we're not talking about when it changes from increasing or decreasing. We just need to know what the critical values are. So if you find that first derivative test, find those critical values. Okay, the second step is going to be to plug values into the original function to get outputs. Okay, so let's just make a quick table off to the side with x values and y values. Let's say x, y, or we could say x and f of x if we want. So our x values that we're going to plug in 0, and we're going to plug in 1. But we're not going to plug in a negative 1 here. And why I'm not going to plug in a negative 1 is that it doesn't fit in my interval of 0, 2 that we're taking a look at this graph on. So it says find the absolute min max from 0 to 2. So if that graph extends beyond 0 or 2, we're not going to consider it. So negative 1 is less than 0. We're not going to consider that in this problem. So in this problem, we're only looking at 0 and 1. So all I have to now do is take 0 and plug it into my original equation to find out what the output is going to be. Well, anything times 0 is 0, so we're just left with a regular old 1. And we're going to do the same thing with an x value of 1. And in this case, we get, well, 1 to the 4th is 1. 1 squared is 1, so I'm going to make that negative 2 times 1 plus 1. And in this case, we get 1 minus 2 plus 1. And then that gives me negative 1 plus 1, which actually gives me 0. Okay, so now what we have here are the output values, and we can actually start to consider what is going to be a max and what is going to be a min. But before we do that, remember we also need to check the endpoints. So we plug the values into the original function to get the outputs, which is perfect. Now what we're going to do is we're going to plug endpoints in and find outputs. All right, so what are our endpoints? Our endpoints are 0 and 2. So let me go annotate that up above. These are our endpoints, 0 and 2. Well, we've already plugged in 0, so now what we need to do is we need to also plug in 2. And we're going to do all of that math with the endpoint of 2 to see if my graph, as it extends past that max and min, even if it doesn't have a horizontal tangent, if it could still have another max or min. So 2 to the 4th power is going to be 16. Minus, this is going to give me 2 times 2, which is 4. 4 times 2 is 8. Plus 1 is going to give me 8 plus 1, which is 9. Okay, so now we have enough information to be able to answer this question. What are the absolute max and min in this problem? I just have to look at these three numbers and be able to decide which one is the smallest and which one is the greatest. So right here, we can see, I'm going to circle this one. This is going to be our min, our absolute min. And this 9 is going to be our max, our absolute max, because those are the greatest and smallest numbers as outputs in this function. So we're going to have an absolute max of 9 at x equals 2. And we're going to have an absolute min of 0 at x equals 1. So reviewing these steps, one thing that you need to consider is we can find our maximums and minimums using critical points, critical values, but that doesn't necessarily tell us the absolute max and min. We just have to then also plug in the endpoints to see if those extend past those relative max and mins. To find out which ones are the absolute, we just look at whatever outputs are the biggest and the smallest. And those are our absolute mins and max. And that is the extreme value theorem.